Hello, everyone. Today we'll talk about GIT and GitHub, specifically about version control systems. I'll be explaining it simply. If you need a scientific and detailed explanation, please refer to the documentation. Additionally, there will be extra instructional videos attached to this lesson, fully exploring these concepts. I'll show you exactly what you will use daily in the project creation process. Brief definitions. GIT is a version control system. It allows you to save snapshots of your code as logical segments are completed. For example, you added a form, saved a new version, added a feature, saved a new version, saved a new. Thus, all these versions are saved on your computer, and you can view the history of your project and revert changes if necessary. After you've done this, a GIT repository is created. This is information about all changes in your code. You need to send it somewhere so that other team members can view it, or so you can deploy your code to a server. For this, you need to use a hosting service for GIT repositories. The most popular hosting service for GIT repositories is GitHub. It's simply a place where GIT repositories are stored. GitHub has alternatives like Bitbucket or GitLab. You can switch to them when you find something lacking in GitHub. Until then, I recommend just using GitHub. Git also has alternatives, but they are currently not popular, and I don't think you'll need to work with them. Alright, you should already have Git installed. It can be downloaded from the official website, and on GitHub, you need an account. Let's now proceed to using Git in our project. At the moment, our project doesn't have Git. We haven't connected it yet. To initialize Git in the project, you need to run the git init command. We've done git init. Now we have Git in the project, but it's still completely empty. To check the status of our GIT repository, we enter the command git status. What do we see? It tells us that there are no commits yet, and we have some so-called untracked files. Specifically, this includes our entire web app folder. Now, look. To save a version of our code, we need to make what is called a commit. And the whole history of our project is simply the history of our code. Each commit is information about all changes made at that step. To commit, you need to decide which changes in our code we want to add to this commit. What kinds of changes are there? Has a file changed? Or has a file been added? Or the file got deleted? Sometimes the file permissions change, but the main three scenarios are the file was deleted, changed, or added. Most often during development, you need to commit all your changes. How to determine what you want to commit? You write git add and, for example, can specify a file name like index.html. Here, so web app index.html. Check git status. It says changes to be committed. So, if we commit now, only these changes will be committed. Created index.html file. We need all the files though. So often you just type git add -a, enter. Again, git status. Please. You have these changes to be committed. It means you haven't committed yet. You've only selected what you'll be committing. Now make the commit once you're sure that you're committing exactly what you want. Literally, everything. Command git commit. -m. It means message. And type the message. A classic first commit message is initial commit and commit enter. Let's see what it said. It says the commit was created. Here's the info. Let's enter git status. That's it. Nothing to commit. Working 3, clean. It's worth mentioning branches. By default, our main branch is called master. If we want, we can create additional branches to branch out our code's flow. This is usually a simple example. I create 2 branches, development and master. Development is done in development. When all developers are satisfied with the development branch, they merge it into the master branch, and they push the master branch to the server where our code runs in production. But right now, most likely, we're developing solo, and we're basically fine with doing everything in the master branch. If you're interested in learning more about branches, please watch the more detailed tutorial video linked to this lesson, or read the official documentation. All right, we committed, and now it just exists in our system. How to view information about the commits made? You can write git log. That's it. There's an initial commit. The author is visible, and also the hash of this commit. Now here's the thing. We want to, ideally, send all our code to GitHub so that later we can, as I mentioned, upload it to the server or hand it over to a colleague for development. All right, now let's go to GitHub and create our repository. So, creating a repository on GitHub, click New on the main page, name the project, make it private, completely free. Do not create a default README file. We need a truly empty repository. The repository is being created, and we already have an existing project. We need to connect it to this repository. For this, there is a command, git remote add origin. What does it mean? We just use the git command to determine that a remote repository exists. There's the remote command, some of our remote repositories. We add a repository. The key name origin is the default name for our main remote repository. Next is the address of this repository. We run this command. Here we just linked our local Git repository with the remote one, but haven't pushed the code yet. Now we need to, as it's called, push our code to GitHub. For this, we usually just write the git push command. But now we can't do that yet because we need to specify where to push by default. A specific command is suggested to us, because by default you need to push there, just once. Call it. Then you can just write git push all the time. Run this command. Look, all done. Now let's check GitHub. Refresh the page. Here you go. We write our project file. Now we see src apt.sx. That's it. Here's our code. Let's quickly go through it all again. Add a line here. Saved. Git status. We see that a file was changed. Git add all. Added. Again, git status. Git status doesn't need to be written so often. It's just for illustration. We see that the changes to be committed are identified. A modification to the apt.sx file will be added. Now we need to commit. We write a message. Messages should be somewhat reasonable. Here we literally added a bit of garbage, so let's write that. This is just trash. Git status. Everything is committed. Let's look at GitHub. Nothing has changed on GitHub because we haven't pushed to GitHub yet. Pushing to GitHub. This is the git push command. Pushed. And please, everything is there. Let's take another look. Updating the file. Here's our line. Great. What should be noted? Your commits should be frequent. Try to tackle one specific narrow task from start to finish at a time. After completing it, commit. This is the correct approach. Always give appropriate names to your commits. Also, for general understanding, so you know when you commit, what's happening, where this information is stored. So here we only see the web app folder, but in reality, it's not the only one here. If you look at all the folders in this project, there's the .init directory. And that's where all the information about commits, changes, etc. is stored. You should never need to go into it. all management is done through the git command. Git support is also available directly in VS Code. It's convenient to work through it, but it's still better to understand how it works. I've just shown you how it works in the terminal. Let's see what we have in VS Code. There's this icon with branches. We go into it, refresh, and it shows us the changes we have. We can click on this file. It will show us what was changed and what it was turned into. It's like typing git status or using the git diff command. It will show you the same. Then, for example, you want to add it. Previously, we did it using git add. Typing git add web app src apts sx is the same as clicking on this plus sign. We clicked. There you go. Again, we type git status. Let's see how it looks here. Here you go. It's added. And we can click back minus. It will return us to the previous state. Then, if you click the plus here, it's like hitting git add all. This suits us perfectly as well. Adding here, now we can enter our messages. Let's see what commits we have now. Here's git log, add some trash, initial commit. And you can also view all commits here in VS Code. Here you go. Initial commit, add some trash. They're all here. Our branches, our remotes, and so on. Okay, let's make a commit through VS Code. Add more trash. Commit. That's it, please. We've committed. All the same. Here are our commits. Add some trash. Add more trash. You can also push through this thing. So we click on the 3 dots here and select push. Let's check it out. Ideally, we've already pushed. Let's see if a number 4 appeared here. Yes, you see a 4 appeared here. Personally, I prefer to combine terminal commands with using VS Code. For example, I often do git push through the terminal. Checking which changes have been made in the code is indeed more convenient through VS Code. Do whatever you like best. If something relevant doesn't appear here, you can click here and it will show up. Another very important command that you won't use much in solo development. But I can't not mention it. It's git pull. It's the opposite command to git push. It allows you to pull the latest changes from a remote Git repository. But since we just push something there, our version is the latest and most up-to-date. Accordingly, it tells us that everything is already up to date. These commands will be enough for you to manage the market for local development. Thank you for your attention. Let's move on. One moment, I forgot to tell you about the file called gitignore. And this is a very important file. Let's take a look at it. Gitignore defines all the files that should be ignored by the version control system. So, what often turns out here is what's most important. It doesn't fall into the version control system. We only need the package.json file, which defines our dependencies, and the pnpm.log file, where they are, so to speak, specified to enter the version control system. The node modules themselves will be installed each time on the system where our project is being set up. For example, the dist folder with our compiled application lies in gitignore, because again, this folder can always be built locally or remotely, given all the source files. There are also various log folders, system files, and editor files defined here that we don't need in the version control system. As we can see, files that fall under the description in gitignore are highlighted in gray. And accordingly, when we commit our project, information about these folders does not get included. That is, our version control system considers these things to not exist. For illustration, you can take a look. Look at our code on GitHub, and as we can see, in the web app folder, the not modules folder indeed doesn't exist. Also, the dist folder doesn't exist there. During development, you will periodically need to add something to this file yourself if you understand that these files aren't needed in the version control system. What that will be, we will find out later, because we will add files here. That's definitely all now. Thanks again. Let's move on.